Hi, this is Dacia Cipher, and I am doing a demonstration of how to compute a Pearson product moment correlation coefficient using a computational formula in the fourth edition of the Grove and Cipher workbook. Using some example data from a survey study by Urban and colleagues, we are looking at two selected variables from a much larger study of newly licensed nurses. Among many variables, they were assessed for levels of perceived stress, where higher numbers are indicative of higher levels of stress, and levels of resilience, where higher numbers are indicative of higher levels of resilience. And as you can see in table 29.2, we have the data laid out in columns. So we have 20 participants out of, this is a subset of a much larger data set, but I selected 20 for this example so that it could be easily computed by hand. And you have the stress values in the first column, the resilience values in the second column. We've labeled stress X and resilience Y here, but they could be switched where resilience is X and stress is Y, and we'll get the exact same Pearson R value. So as a reminder, the Pearson R is assessing the extent of the linear association between two variables. So to compute the Pearson R by hand, we have, of course, our two variables in columns. And then we have summed the stress values together, all 20 stress values, and I've listed them at the bottom row in bold font here. So the sum of all of the stress values for these 20 participants is 396. The sum of all of the resilience values for the 20 participants is 68.02. And then you see three extra columns here. Now, these three columns are going to correspond to the Pearson R formula. So X squared means that we took each participant's value of stress and squared it. So 24 squared is 576. 7 squared is 49, and so forth and so forth and so on, all the way down. And so you can see at the very bottom in bold font, we have summed all of the X squared values, and that equals 9,086. And then we've done the same thing for resilience, or Y. We squared every participant's value of resilience and listed that here, summed all 20 participants' values up, and that's 246.37. Finally, we have a cross product column where we've multiplied every participant's stress value with every participant's Y value, Y resilience value. So 24 times 4.17 equals 100.08, and so forth and so on for every single participant. And then, yes, again, we have summed all of these cross product values, and that is 1,281.37. So we have 5 values at the bottom of each column in bold font, and they represent summed values. And we're going to see how to plug those in here in the formula. So here is what we would call the computational formula for the Pearson R. Computational because if you line those 5 columns up correctly and obtain the correct sums, then you would simply just insert those values into the formula. And so one part that is missing that isn't necessary in the table is the sample size. So the sample size is in here. So wherever you see in the 3 places in the data set, we would put 20 because there were 20 participants in this particular example. So let's start with the numerator. The numerator is n times the sum of the cross product, x times y, minus the sum of x times the sum of y. So let's look at that numerator. Here we have n is 20. The sum of the cross product is 1,281.37. You see how that's inserted here. And then minus the sum of x, which is the sum of stress, that's here. And that's plugged in here, 396 times the sum of y. That's the sum of resilience. That's 68.02. You can see that entered here. So you can solve for the numerator of the R here with a calculator. And then the denominator. Now the denominator does have a square root sign, so we can't forget to take the square root of the values when we have worked the math inside of the brackets. But we have, again, sample size of 20, and then we have the sum of x squared, which is the value here, the sum of x squared, stress squared. So that would be 9,086. And as you can see, that's entered here. The sum of x squared minus the sum of x in parentheses and then squared. So that would be minus the sum of stress, 396, and then squared. And then we'll do the same thing for y. We have n again times the sum of y squared. So that's the sum of resilience squared here, 246.37, minus the sum of y, which is here, sum of y squared. So you have to solve for that denominator, and the contents of what are within this bracket is 24,904, and within this bracket is 300.77, and then you would multiply those together, and then don't forget to perform the square root. And that solves down to a numerator of negative 1,308.52. The denominator is 2,738.86, and that solves to a Pearson R value of negative 0.48. Now, with the degrees of freedom formula for a Pearson R is the sample size minus 2. So our degrees of freedom for this particular example are 18. So if we are not using a computer and statistical software and we're looking at our critical R value table, then we would be using degrees of freedom of 18, and we would compare our tabled R to the obtained R here, and that our obtained R of negative 0.48 exceeds the tabled R in the Appendix B for degrees of freedom of 18. And I do want to note that this particular R is negative. So that indicates that this is an inverse association between stress and resilience, meaning that higher levels of stress are associated with lower levels of resilience. So the tabled R value is 0.4438 at degrees of freedom of 18 at a set alpha level of 0.05. Our absolute value of our obtained R of the absolute value would be 0.48, does exceed that tabled R 0.44, indicating that we have a statistically significant Pearson correlation between stress and resilience. So in a subsequent video, I'll show you how to compute this R using SPSS, and you can obtain the exact p-value associated with this R of negative 0.48. At this point, though, we can conclude that there is a significant correlation between stress and resilience. R equals negative 0.48, P is less than 0.05. Higher levels of stress are associated with lower levels of resilience and vice versa. So the next subsequent video will show you how to check your work using SPSS, and write a final interpretation using APA format.